This video will help you memorize the unit circle, which is a crucial skill for the AP Calculus exam. One important thing to note about the unit circle is that it is embedded in the traditional coordinate plane. So I'm going to go to a blank version of the unit circle. And for starters, this is the origin. This is the point 0, 1. One, 0, and so on. Now, the first thing to memorize about the unit circle is that any of the ordered pairs represent the cosine and sine of the related angle, so in that order. So cosine theta, sine theta. This is to me, the first step in memorizing. It's easy to memorize this because cosine alphabetically comes before sine, C before S. So again, the x-coordinate of the related angle is the cosine for that angle, and then the y-coordinate just is the sine. Now some students struggle just understanding what the angles are at all. I think I can clear that up for you. So let's start with quarters of pi. First things to memorize are that this angle would be 0 radians, the positive x-axis, and then half of a turn is pi radians. So you definitely have to know that. But if you just look at, say, quarters of pi, for example right here, this is 1/4 of the way to pi. That angle is going to be pi over 4, obviously. Now, the next one is 2 pi over 4, then 3 pi over 4. And people start to get confused because this angle, of course, is not expressed in fourths, but it is 2 pi over 4. Okay, so you can recreate it at any time on your own, but nobody talks that way 2/4, so we do a half, so it's pi over 2. Okay, so 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, but nobody talks that way, and then 7 pi over 4. Okay, the other major divisions come from the 30, 60, 90 special right triangle. This is, of course, 1/6 of pi. You'll know it as 30 degrees, but nobody uses that on the AP exam. So this is 1/6 of pi, which is pi over 6. Okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. It's really easy once you understand it that way. So 1 pi over 6, 2 pi over 6, nobody talks that way, pi over 3. 3 pi over 6, already done. 4 pi over 6. 5 pi over 6. 6 pi over 6, 7 pi over 6. 8 pi over 6. 9 pi over 6, already done. 10 pi over 6. 11 pi over 6. Okay, that's a start, just getting the angles under control. Now, this next part, memorizing the actual coordinate pairs and their values, this is a tip I got from Tom Wade, former student. He noticed a pattern in the sine and cosine. Again, the sine is the y value. He noticed the following pattern starting at the positive x-axis at 0 radians. Okay, and that pattern is 0, 1, 2, 3. Okay, so, and these are, obviously there's more to it with the square roots and all that, but I'm assuming you're going to memorize that. So, and then coming down with the cosine from the top, from pi over 2 radians, cosine 0, 1, 2, 3. Let me draw that out for you. So, of course, in the end, you have to have these memorized. And sine comes second. That's the y values in the ordered pairs. 0, 1, 2, 3. Cosine 0, 1, 2, 3. Now, this is a really effective way to memorize it. I used to see Tom and other students counting on their hands. So this is a picture, an awesome picture of my left hand. And again, you can think of this, of course, as 0 radians, and then this is pi over 2 radians. And many of the questions just operate in the first quadrant and are really easy in that respect. So you can see, obviously then, this would be your pi over 6, your pi over 4, and your pi over 3 in terms of the angle measures. And it's really just a nice way to work this. You just work up and down 0, 1, 2, 3 for the sine, and then 0, 1, 2, 3 for the cosine. Hope that helps. Now the only remaining issue is getting into the other quadrants, and there's an acronym that you may have seen already expressed on this completed unit circle, and it is all students take calculus. This of course is false, but it's a useful reminder going in order of the quadrants, because this of course is quadrant 1, 2, 3, and 4 operating in a counterclockwise direction. This will help you to construct any part of the unit circle that's not in the first quadrant, because all of the 3 major trig ratios, sine, cosine, and tangent, are positive in the first quadrant. Only the sine is positive in the second quadrant. Only the tangent is positive in the third quadrant, because a negative divided by a negative is a positive. And then only the cosine is positive in the fourth quadrant. So again, if you just pick a random value, like say 4 pi over 3, and say you have to find the cosine and sine of that value. Okay, you might not remember everything about every quadrant, but if you go back to this quadrant, you can see that the y value for this will be equal but opposite to the y value for that. Okay, like the same height that this is above the x-axis, this dot is that same height below the x-axis. So there's a correspondence here. So if you've done your good memorizing, you know that the sine value here is square root 3 over 2. So the sine value in this quadrant will be negative square root 3 over 2. Okay. And again, these ordered pairs, they go together, so in the other case, since that's square root 3 over 2, then the cosine in that case is 1/2. Here the cosine will be negative 1/2. And naturally, like I said before, if you're asked for the tangent, you divide sine by cosine. So for example, tangent of 4 pi over 3 is equal to sine divided by cosine. 2 negatives cancel, the 2's cancel, and you get the square root of 3. Because the square root of 3 divided by 1 is the square root of 3. So there's an example of using this technique. Let's try it in the second quadrant, say, at 5 pi over 6. Say you need the cosine or the sine of 5 pi over 6. Again, you might not have it memorized, but the height here of that dot is the same as the height for pi over 6. So it's off screen right now. You should know by this point 0, 1, 2, 3. Okay, it's the 1, so 1/2 is going to be the height. Okay, so that's identical for 5 pi over 6 and for pi over 6. So then here we know that only the sine is positive in the second quadrant, and the cosine is going to be negative square root 3 over 2. Now another way to think of this negative sign, it's just really obvious, is that since the cosine represents, or just is, the x-coordinate of the point involved, well, that point is left of the y-axis, so obviously you're going to have a negative value on the x-coordinate for that point, and then the y value will be positive because you're above the x-axis. So that's really the way I think of it. I don't use the all-star trig class thing, or all students take calculus or whatever you like. I don't really use that, but if that helps you, more power to you. So I hope this whole lesson helps. A really good way to practice is just to get a hold of blank unit circles and then try to construct your own. Do this a few times. It just so happens I have some in the classroom, so you can certainly ask me for them, and I'll probably give them to you whether you ask or not. So best of luck, and let's get right answers instead of not.